Anyway, now we try to solve an hypothesis which is more complex, but is an expected increase in nominal money stock. And we finish. What is the dynamics of the exchange rate in case we have an expected increase of nominal money stock? So the hypothesis is that MT, okay, the nominal money stock MT is equal to M0 for each T lower or equal to T1, and MT is equal to M0 plus epsilon for each T greater than T1, but now the difference is that we are in T0, which is lower than T1. So this is an expected increase in nominal money stock. It's for the future. It's not a sudden increase. So the hypothesis is that we are in T0 and the nominal money stock is equal to this T is equal to M0. But in T0, we know that in T1, the future time, the nominal money stock becomes equal to M0 plus epsilon. So the nominal money stock is equal to M0 until T1. This is the hypothesis. But we know in T0 that in T1, the future day, the nominal money stock will increase by epsilon, and this increase will be permanent. So in this case, we have also the case in which the central bank anticipate that in times in the future day will increase the nominal money stock. Okay? In this hypothesis, we need to derive the dynamics of the exchange rate, which is different with respect to the case in which you have a sudden increase in nominal money stock. This is an expected increase in nominal money stock, and what is different is the dynamics between T0 and T1, between the day in which you have the announce, okay, and the day in which you have the actual increase of the nominal money stock. The problem is derive these dynamics. Because we know that until T0, the nominal exchange rate is equal to M0, because the agents expect that the nominal money stock is constant, is equal to M0, but something changed in T0. In T0 we have the announce of a future increase in nominal money stock. So how to derive in this case the dynamics of the exchange rate? We need to apply the same integrals, but in this case the integral is st equal to 1 over 2, which multiplies the integral between t and t1, because you have two parts between t and t1, and between t1 and plus infinite, because the fundamentals are different. in the two intervals. So you have this part and you have also another part, 1 over alpha 2, integral between t1 and plus infinite. You need to split the fundamentals. Sorry?
Why not 0 and t1?
Why not 0 and t1? Because we need the function of the exchange rate s of t, s respect to time. If you put 0, you get s0. Okay, you need s in function of time.
Why not t0?
Why not is 0?
T0.
T0, because you need the function, this is valid for each t between t0 and t1. So you need to discount until t, not t0. Because if you discount until t0, you have the value only in t0. But you need the dynamics between t0 and t1. Because you have to consider all the time between t0 and t1. So you need to use t. Okay? What is the other part? The other part is between t and t1, the nominal money stock remains equal to m0. After t1, the nominal money stock becomes m0 plus epsilon. And then you have to multiply it by the same factors. E to the power of minus v minus t over alpha 2 in the v, e to the power of minus v minus t over alpha 2 in the v. The same factor. You need to split the integral because the fundamentals are different between t0 and t1 and then after t1. We need to compute again the same integral, okay? The first integral is t equal to 1 over alpha 2. We can put outside the integral what? 0, but also e to the power of t over alpha 2. And the value of the integral is the same as seen before, minus alpha 2, which multiplies e to the power of minus v over alpha 2, but between t and t1 is the difference. The second part is 1 over alpha 2. We can put outside the integral m0 plus epsilon, which multiplies e to the power of t over alpha 2, and we have the same integral e to the power of minus alpha 2. Okay, put here minus alpha 2 e to the power of minus 2 over alpha 2, but between t1 and plus infinity, because the value of the integral is the same, minus alpha 2 e to the power of minus 2 over alpha 2. This multiply here, okay? The same expression, so we have st equal to 1 over alpha 2 and 0 e to the power of t over alpha 2. The integral is minus alpha 2 e to the power of minus 2 over alpha 2 between t and t1. Then we have plus 1 over alpha 2 m0 plus epsilon e to the power of t over alpha 2, which multiplies the same integral, minus alpha 2 e to the power of minus 4 over alpha 2, between t1 and plus infinite. The same, okay? Now, computing the value of the integral between the two extremes, we get 1 over alpha 2 m0 e to the power of t over alpha 2. Alpha 2 and alpha 2 simplifies, okay? And here's the same. Okay? We can simplify. What is the value of this function in t1? Is minus e to the power of minus t1 over alpha 2. The value of this function in t1, substituting t1 in v.
Sorry,
Yes?
why there is 1 over alpha sure in the last equation if we simplify alpha
What?
sure?
Sorry?
We simplify alpha sure with alpha sure.
Yes.
And in the last equation,
Yes?
there is 1 over alpha sure times m0 times e.
Epsilon times e to the power of t over alpha 2 times minus alpha 2, which multiplies e to the power of minus v, this part, okay? Here. You can simplify, you can put outside minus alpha 2. You can simplify with alpha 2.
But you simplified that.
Sorry. Yes, you're right. You're right. I was checking just the first equation. Okay. Yes. Minus the value of the function in t. So we have minus e to the power of minus t over alpha 2. Plus m0 plus epsilon, which multiplies e to the power of t over alpha 2. And here you have, what is the value of the function if v goes to infinite, plus infinite, is 0. Minus the value if v is equal to t1, so is minus e to the power of minus t1 over alpha 2. So you get, the first part is, we need to multiply, okay? So you get m0 e to the power of, this is minus, so this is minus, okay, minus e to the power of t minus t1, perfect, over alpha 2. Then you get plus m0, because you get m0 e to the power of 0. Then you need to multiply m0 plus epsilon times 0, there is no problem. Times the other part, you get plus m0 plus epsilon, which multiplies again t e to the power of t minus t1 over alpha 2. The final result is m0 plus epsilon, which multiplies e to the power, we can write, it's better to write in this sense, minus t minus t1 over alpha 2. This is the final dynamics of the exchange rate between t0 and t1. This is the dynamics. Why I put the time in this way? To highlight the discount minus the period. Okay.
But we multiply epsilon and also m0 only epsilon.
Because m0 simplifies.
Okay.
If you compute this times this minus plus m0 which multiplies the same with 0, I simplify it. This is the dynamics of the exchange rate between. Finish the computation is finished. Yeah. So this is the dynamics of the exchange rate between T0 and T1. As you can see, in T0 you have a jump in the exchange rate, yes, because you can substitute T0 and T, but the jump is not equal to epsilon, it's lower than epsilon. Is the discounted value of epsilon between T0 and T1. I show you the dynamics. No more computation, okay? Just the dynamics. Just the dynamics and the economic intuition we finished. The economic dynamics of the exchange rate in this case. Oh. Okay. Exchange rate. Here you have T0 and T1. Okay? Until T0, the exchange rate is equal to M0. Why? Because the expectation is a permanent nominal money stock equal to M0. In T0, this is M0 plus epsilon. In T0, you have a jump in the exchange rate, but this jump is lower than epsilon. Is equal to, last equation, is equal to, using the equation, is equal to epsilon, which multiplies e to the power of minus T1 minus T0 over alpha 2. So this jump depends on the distance between T1 and T0, between the time of announce and the time of actual increase in nominal money stock. This distance, okay? Anyway, the dynamics after T0 is an exponential dynamics in T, and you have an exponential depreciation this way, okay? Okay, until T1. In T1, the exchange rate will be equal to M0 plus epsilon forever. This is the dynamics. And why we have this dynamics? So, the dynamics, the response of the exchange rate to this announce, this monetary policy announce, is that in T0 you have a jump, yes, but it is lower than epsilon. It's the discounted value of epsilon, because the actual increase in nominal money stock is in T1, it's in fusion, okay? And this is the value of the jump, is the discounted value of epsilon. Then you have a depreciation exchange, continuous depreciation in exchange rate until T1. In T1, the exchange rate remains equal to M0 plus epsilon, because from T1 the nominal money supply will be equal to M0 plus epsilon. The problem is to explain this economic dynamics, and you need to explain this economic dynamics, because what is the effect on real money stock in T0? In T0 you have no change in nominal money stock, but you have a depreciation in the exchange rate. So the real money stock decreases in T0. in T0, due to the fact that you have this differentiation, the real money stock, which is MT minus ST, is the real money stock, assuming that foreign prices are zero, decreases. Because of the increase, because of the exchange rate depreciation.